this lesson, we're going to learn another way to solve quadratic equations, the quadratic formula. As I'm sure you've discovered, sometimes there are polynomials, even just quadratics, that just don't factor. So we need another method for solving quadratic equations that will work when you can't factor it. The quadratic formula can be used to solve any quadratic equation, although as you'll see it takes a bit of work, so I recommend still trying to see if you can factor first. What is the quadratic formula? The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice the plus or minus before the square root. That's the thing that gives us the two roots of the quadratic equation. Really what we have to do is evaluate the formula when adding the square root, then evaluate it again when subtracting the square root. Those two results are the two roots of the equations. But where do the a, b, and c come from? Those are values from the equation itself. We have ax squared plus bx plus c equals 0. A is the coefficient of the x squared, b is the coefficient of the x, and c is the constant. Notice that, like we did when we were factoring, we have to have this equation equal to 0 before we can use the formula. Before we go any further, I want to give you something to help you tackle the most difficult part of this lesson, memorizing the formula. Sing this song to yourself a few times, and I'm sure you'll have it memorized in no time. Here it goes. Negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Now that we're familiar with the formula, let's try to use it to solve the equation 3x squared plus 8x plus 5 equals 0. First, always write down the formula so you can see it in front of you as you use it. The next thing we need to do is identify what a, b, and c equal. Looking at the equation, a is the coefficient of x squared, so in this case it equals 3. b is the coefficient of x, so b equals 8. And c is the constant, so c equals 5. The next thing to do, now that we know what a, b, and c are, is to substitute them into the formula. Anywhere you see an a in the formula, replace it with a 3. Next, we replace the b's with 8's. Notice the formula calls for negative b, so we now have a negative 8, and it also calls for a b squared, so we have 8 squared. Finally, replace the c with a 5. Now that we have all the proper values in place, all we need to do is simplify. First, let's simplify what's in the square root. 8 squared is 64, and 4 times 3 times 5 is 12 times 5, which equals 60. So we have the square root of 64 minus 60, which is the square root of 4. Also, notice in the denominator that 2 times 3 equals 6. So now we have negative 8 plus or minus the square root of 4 all over 6. Now, the square root of 4 is 2, so we need to find negative 8 plus 2 over 6 and negative 8 minus 2 over 6. Negative 8 plus 2 is negative 6, but negative 8 minus 2 is negative 10. So now we have negative 6 over 6 or negative 10 over 6 as our two roots. If we reduce these values, we have our two roots. Negative 6 over 6 is negative 1, and negative 10 over 6 reduces to negative 5/3, or you could write it as negative 1 2/3. Now let's try to solve the equation 6x squared minus 3x minus 4 equals 0. First, we write down the formula, then identify a, b, and c. A equals 6, the coefficient of x squared. B equals negative 3, the coefficient of x. And c equals negative 4 is the constant. The next thing to do, now that we know what a, b, and c are, is to substitute them into the formula. Anywhere you see an a in the formula, replace it with a 6. Next, we replace the b's with negative 3. Notice the formula calls for negative b, so we have a double negative, and there's also a b squared, so we're going to have a negative 3 squared. Finally, replace the c with a negative 4. Now that we have all the proper values in place, all we need to do is simplify. First, let's simplify what's in the square root. Negative 3 squared is positive 9, and 4 times 6 times negative 4 is 24 times negative 4. 24 times negative 4 is a negative 96. So we have the square root of 9 minus a negative 96, which is the square root of 9 plus 96. Also, notice that in the denominator 2 times 6 was 12, and notice our double negative gave us a positive 3 in the numerator. 9 plus 96 is 105, and you can use a calculator to find the square root of 105, which is 10.2 rounded to the nearest tenth. So now we need to find 3 plus 10.2 over 12 and 3 minus 10.2 over 12. 3 plus 10.2 is 13.2, but 3 minus 10.2 is negative 7.2. So we have two roots as 13.2 over 12 and negative 7.2 over 12. We can use the calculator to simplify these values, and we have our two roots. 13.2 over 12 equals 1.1, and negative 7.2 over 12 equals a negative 0.6. Our last example is a little different, but it's one that you need to know how to deal with. Given the equation x squared plus 3x plus 7 equals 0, we'll start the same way we have before. Write down the formula, then identify a, b, and c. A is the coefficient of x squared, so in this case it equals 1. B is the coefficient of x, so b equals 3, and c is the constant, so c equals 7. Now we'll substitute a, b, and c into the formula. Anywhere you see an a in the formula, replace it with a 1. Next, we replace the b's with 3. Finally, replace the c with a 7. Now that we have all the proper values in place, all we have to do is simplify. Here's where the difference occurs. When we simplify what's in the square root, we have 3 squared equal to 9, and 4 times 1 times 7 equal to 28. This gives us the square root of 9 minus 28. The problem is that 9 minus 28 is a negative 19, so we're trying to take the square root of a negative number. If you tried punching that into your calculator, it would give you an error. The fact is, unless you're in a higher level algebra and have learned about imaginary numbers, there's nothing more you can do. So for your answer, you can just write that x is complex. There are no real roots. That means our roots are not real numbers. Now that you've seen a few of these worked out, try some of the activities to practice using the quadratic formula on your own. Remember, be careful with your arithmetic.